Hey man, say man, back at it again with another what? Math video. All right, ladies and gentlemen, thank you for joining me today. Today we've got another lesson focus, okay? Just remember we're subtracting fractions today, but our lesson focus says Gavin has 2/3 pints of water left in his water bottle. He drinks 1/2 pint. How much water is left in the bottle now? So we should have already identified that he starts with 2/3, he drinks 1/2, and we want to know what's left. So if I start with 2/3 of a bottle of a drink, let's say Gatorade, 2/3 bottle of Gatorade, and I drink 1/2. When I drink 1/2 of the bottle, am I losing what's in the bottle or am I actually adding to it? Let's think about that. If I'm drinking, am I losing or am I adding? Right? I'm losing. So half of that bottle is leaving out of the cup and going into my body. So it's actually leaving that cup or the bottle. So we've got to figure out if Gavin drank 1/2 of 2/3, how much of that Gatorade, I'm going to say Gatorade, how much of that Gatorade does he have left? If you see my screen, I've actually already pre-placed the fraction models 2/3 and 1/2. And what I'm gonna do is something really cool that I discovered that we could do to really represent like a cup of water, or in your case, what you've seen on your screen before this was actually the visual model of bottles, which was pretty cool. So just think as these fraction bar models as like actual bottles of juice or something, okay? So if we start with 2/3, we drink 1/2, we want to figure out what is this amount right here that's left over. How much is that? How much is that? Okay. So what I'm going to do, I'm going to show you um, that when we want to create equivalent models, what we can do, basically, if you take your marker, right? If you take your marker, I revealed my work over there. If you take your marker and break it, take your marker and break it down. I'm like, Mrs. Spencer, what are you doing? I'm trying to show you that we can actually break this guy down. Ah, so that is, we can break this in half, break this in half, and then break this in half. So now we should have 1, 2, 3, 4, 5, 6. So now these both of these guys are broken into 6. It's supposed to be equal parts, guys, but as you know, Mr. Spencer's lines are just not the very best. But what I did, I broke both fractions into 6 equal parts. And you're like, 6 equal parts, Mr. Spencer, why did you just randomly break both of these fractions into 6 parts? If you take a look over here on the right-hand side, let me show you why I did that. If I could move my face, what is going on? What is going on? Here we go. Shoop. I'm going to move over there. Taking a look at the right-hand side, what I did, I listed my denominators. I listed the multiples of my denominators. And you're like, denominators? The numbers of the bottom of the original fraction. So 3 and 2. I listed their multiples to find what is that smallest number that they both have in common. So if I list out my multiples, 3, 6, 9, 12, 15, I stop at the fifth one just because. And then I list out the multiples of 2, 2, 4, 6, 8, 10. I listed up to 5 of the multiples just because. I noticed that the smallest number that both 3 and 2 have in common when I list my multiples is 6. Excellent job. It's 6. And you see that because I've circled it. This is the smallest number that both 3 and 2 have in common when I list my multiples. So now that I know my least common multiple, or my least common denominator, however you want to call it, I'll write over here LCM is equal to 6. I know that my new equivalent fractions are both going to share that denominator of 6. And when you see 6, just remember that is what the fraction bar models were broken into, 6 equal parts, right? So if I have 2/3 as my original fractions, I want to know 2/3 times what gives me 6, or the denominator of 6. And what I mean by that, basically, if I look at my denominator of 3, 3 times what gives me 6? Well, I know 3 times 2 gives me 6, and I also know that 6 is the second multiple of 3 when you list them out. So 1, 2, bloop. 6 is the second multiple. So 3 times 2 gives me 6, or 3 twice gives me 6. So that means I have to multiply my numerator times 2. Whatever I do to the bottom, I do to the top. So 2 times 2 gives me 4. So this means, or this tells me that 4 over 6 is equivalent to 2 over 3, and that is correct. If I multiply 2 times 2, that gives me 4, and 3 times 2 gives me 6. So 4 over 6 is equal to 2 over 3. Boom. Now we got our first equivalent fraction. Let's figure out our second equivalent fraction, okay? So I've got 1/2 times what number gives me 6? I know 2 times 3 gives me 6, and I also know that 6 is the third multiple of 2, if you look back at your list, right? So if 2 times 3 is equal to 6, 1 times 3 gives me what? I have to multiply the 1 times 3, because whatever I do on the bottom, I have to do to the top. Some people tell me I'm a beautiful singer. What you think? Oh, 1 times 3 is going to give me 3. 3 is correct. So my equivalent fraction is 3/6. 3/6 is equal to 1/2, or 3 is half of 6. Ta-da! But wait, there's more. We have one more step to do. We figured out that our the question was a subtraction problem. Remember, we're subtracting fractions. So if I have 4 over 6 minus 3 over 6, that's an ugly 3. What is that going to be? 4 over 6 minus 3 over 6. Remember, I have like denominators. So if I have like denominators, I know my denominator is going to stay at 6. And I don't like these 3 numbers in a row. So we're going to hurry this math up. So 4 minus 3 gives me 1/6. And also, I just proved that mathematically. Let me show you. We know that both the 2/3 and the 1/2 fraction bars are equivalent because we broke them down into 6 pieces, both of them, right? So if I have 2/3 minus 1/2, basically this is saying if you take away this, this, and this, if I take this away from this, if I take away the 1/2 fraction model from the 2/3 fraction model, what am I left with? And that little red piece right there, ladies and gentlemen, is 1/6. That represents 1/6 because it's one of the actual 6 pieces that we broke the fraction into. Is 1/6 equal to 1/6? Absolutely it is. All right, ladies and gentlemen, as always, if you need to, you can replay this video, pause it if you need to. But I hope this visual model helps in addition to the great work that your teacher is doing in their class. As always, ladies and gentlemen, I look forward to making my math videos for you all, and I will see you soon. Peace.